It shouldn't be there. Not this early, not this bright, not this evolved, but it is. MOMZ14, an ancient galaxy, barely 500 light-years wide, burning with the light of thousands of newborn stars. Its glow began just 300 million years after the Big Bang, yet it carries the chemical fingerprints of generations of stars that lived and died before it. This galaxy isn't supposed to exist. No central black hole, no slow buildup, just intensity, disorder, and complexity far too soon. Found by the James Webb Space Telescope, MOMZ14 is part of a growing pattern. Tiny red galaxies, compact and luminous, scattered across the edge of time. They defy our models, they rewrite our beginning, and they're multiplying. The early universe is not what we thought it was. MOMZ14 is tiny, only about 500 light-years across. You could fit it inside the Milky Way 100 times over, and yet, somehow, it burns brighter than galaxies thousands of times its size. That brightness is no illusion. It's driven by an intense burst of star formation, like a miniature furnace igniting in the void. Galaxies like this aren't supposed to exist so early. According to our models, the first galaxies were dim, disorganized clouds of hydrogen slowly forming stars. They were supposed to be fragile, metal-poor, barely distinguishable from the cosmic background. But MOMZ14 is none of that. It's alive with activity. Spectroscopic analysis reveals an unexpected signature, nitrogen. A lot of it. This isn't a trace contaminant. It's evidence of several generations of stars that have already lived and died, recycling their matter into the next wave of creation. That shouldn't be possible. To get nitrogen, you need stars to form, fuse, die, and spread their ashes. And that takes time. Time the early universe shouldn't have had. Yet here it is, a cosmic nursery, filled with the ghosts of stars we never saw. And something else is missing. Something that should be there. Most galaxies with this much star formation are powered, or at least regulated, by a central supermassive black hole. That black hole stirs the gas, seeds collapse, balances the growth. But in MOMZ14, there's no evidence of one. No monster at the heart, no gravitational shepherd, just light, dust, and chaos. It's as if this galaxy skipped the rules entirely. And maybe that's not an isolated case, because as JWST keeps looking deeper, more of these screamers keep appearing. When the James Webb Space Telescope opened its golden eye, it wasn't supposed to surprise anyone, and not really. The models were ready. The simulations had been running for decades. We knew what to expect. Faint galaxies, simple chemistry, scattered star formation, ghostly echoes from a universe just waking up. But that's not what we saw. Instead, JWST revealed a universe already ablaze. Galaxies like MOMZ14, compact and brilliant, showing up earlier than they should, and in greater numbers than anyone predicted. At first, scientists hesitated. Maybe it was a calibration error. Maybe the redshifts were off. But as the data piled up, denial gave way to a stranger possibility. The models might be wrong. And not just wrong in the details, wrong at the core. In our standard picture of cosmology, the early universe is a slow burn. After the Big Bang, matter cools, dark ages stretch on, and then, gradually, hydrogen collapses into stars. Galaxies form, merge, evolve. Metals accumulate over billions of years. This version of history is clean, ordered, and above all, predictable. But MOMZ14 throws that timeline out the window. It's too chemically mature. The presence of nitrogen and other heavy elements means that stars have already formed, fused, exploded, and recycled. That takes time. More time than the universe should have had by the moment we see this galaxy shining. And that's not just a curiosity. It's a contradiction. Because if one galaxy breaks the rules, it could be an outlier. But if hundreds do, it means the rules themselves may be broken. These little red dots aren't rare. JWST surveys now suggest they're common, strewn across the early cosmos, like sparks in dry grass. They're building stars 10 times faster than expected and doing it in tiny, tightly packed volumes of space. Why? Some theorists are scrambling for answers. Maybe dark matter clumped earlier than we thought. Maybe cosmic inflation left behind unexpected density fluctuations. Maybe feedback from the first stars triggered runaway starbursts. Every theory tries to preserve the old timeline, to force the universe back into line. But what if the timeline is the problem? What if we've misunderstood how fast complexity can emerge? What if the early universe wasn't gradual, but explosive? What if some unknown mechanism, jump-started structure on a cosmic scale? Because there's more. Recent studies show an unsettling trend: large-scale galaxy alignments. Across distances too vast to interact causally, galaxies appear to rotate in similar directions, as if spun by some primordial force. That shouldn't happen in a random, isotropic universe. The cosmic microwave background says space should be uniform, directionless. But here we are, staring at a subtle pattern where none should exist, and the implications are chilling. If galaxies are aligned, if matter clumps faster than expected, if chemical complexity emerges too soon, maybe we're not looking at flaws in data. Maybe we're staring into the face of a larger, older architecture, one we never imagined was there. An architecture that mocks our models. What if we've been reverse engineering a lie? There's a theory in physics, an uncomfortable one, that maybe the laws we treat as fixed aren't, that the so-called constants, like the speed of light, the strength of gravity, the rules of thermodynamics, may have shifted in the deep past. It's a fringe idea, but MOMS 14 gives it fuel. Because if the early universe evolved too fast, then maybe the universe itself was different, not just in content, but in principle. Some physicists now suggest the possibility of varying constants, that the speed of light may have been faster in the first billion years, that gravity was stronger, that quantum fluctuations were larger, more chaotic, able to seed galaxies before the rules hardened into what we call physics. If that's true, then MOMS 14 isn't an outlier. It's a fossil from a wilder universe, a brief phase where complexity emerged not in defiance of time, but in service of a deeper, forgotten order. And then, something changed. Some models point to symmetry breaking, a moment when forces that were once unified snapped apart. The universe cooled, the constants crystallized, the tempo slowed. The laws we know today came into being, but only after the party had already started. Others go further. They ask, what if this isn't the first time? What if the Big Bang wasn't a beginning, but a rebound? What if MOMS 14 is a leftover from a universe before ours, a galaxy that survived the reset, a rogue structure flung across the boundary of time, surviving just long enough to whisper back, "We were here first." These are wild theories, dangerous even, but they're no longer dismissed out of hand, because JWST keeps showing us things we cannot explain, and physics, despite its elegance, is cracking under the weight of new light. We are witnessing an acceleration, not just of discovery, but of doubt. And in that rush, one truth grows clearer by the day. The universe was never simple. We just arrived too late to see the chaos that made us. The deeper we look, the more the universe resists explanation. It gives us light from galaxies that shouldn't exist, elements forged in fires that burned too soon, structures too large, spinning too perfectly, aligned in ways that shouldn't happen by chance. And yet, there they are. MOMS 14 is just one name on a growing list, a red dot in the black, a signal from the edge of time. But behind that name is a question far older than any telescope. What is this place? We thought we understood the beginning. That time emerged cleanly, that stars followed rules, that galaxies grew from simplicity into structure. But what if it happened the other way around? What if the universe began complex and only pretended to be simple? What if it remembers something we've forgotten? We search for answers in data, spectra, and simulations, but every discovery only deepens the mystery. The silence between galaxies isn't empty, it's haunted by echoes, by contradictions, by a kind of intelligence we haven't yet recognized. And if you've made it this far, if some part of you feels that quiet unease, that tug in the dark, then this journey is yours too. So give this video a like, subscribe to The Cosmic Unknown. It helps more than you think, and it means we get to keep going. Deeper, stranger, darker, because whatever this universe is, it's not done surprising us.